stream. Okay, so these papers are usually more focused on a practical aspect, in particular implementation type of issue. Okay, so so this year we actually have 195 oral presentation and 65 poster presentation. Because of the change of the date of the CE show, so we, instead of extending our conference to Tuesday, we actually compress it to 3 days. So we have a very packed program. Every session is full, and in fact, we have actually had more parallel sessions also this year. Right. So as you Kiko has mentioned, this time around we have 6 keynotes, 5 tutorials, 2 special sessions, and 1 workshop. So basically every session is full. Just briefly, the best paper announcement will be announced on Monday lunchtime. And for the poster presentation, we are actually going to ask the audience to actually choose the best poster, and it will be announced on Monday also. Right. So lastly, check for updates to the program on the website. So if we have any last minute change, we'll just update it. Right. So that's all. Thank you very much again for coming. So I wish you have a very good conference. Thank you.
Now, Hoddie will introduce our first keynote of this edition. Rick, thank you.
Thank you. Good morning, everyone. It's my pleasure and honor to introduce a man I can call my friend, in addition to being a shy at times, but well-renowned and impactful engineer, ICCE member. And I guess I've known Peter something like 20-something years, and leave it there. Peter, as you may know, is the father of QuickTime. And at that time, video on PCs and Macs was nearly impossible. It was a few frames a second, 160, 120 images, things like that. But what's not more important is not just rolling out QuickTime, but rolling out QuickTime with an open structure. The plug-in codecs were available and such. And these are tough things to do from a company the size of Apple. But that had a tremendous impact. It helped drive similar PC development, QuickTime on the PC, and it's just one of the anchor points of the benefits that Peter's brought to this industry. More importantly, in recent years, as multimedia and mobile have come out, and the need for lean and mean code, I mean, if you make the code tight, the device is going to run better, faster, more economically. And I would say perhaps Peter has been able to look at the big picture and translate code as needed down to the tightest thing close to machine as you can imagine. Perhaps second only to Steve Wozniak in the Apple II days, when he was writing code that would fit into ROM and other machines needed cassettes and other things to run their OS. So I'd like to introduce Peter Hoddie, who now will be addressing something we're all concerned about, and the theme of this conference, the Internet of Things. Please welcome Peter.
So many standards to choose from. There we go. So good morning. I'm really pleased to be able to talk to you this morning. Rick asked me to come and talk to you about programming for IoT with kind of a 5-year time horizon. And so I'm going to do that, and my hope is that some of you out there will say this sounds ridiculous, because anything that's 5 years in the future should sound a little bit ridiculous. And my other hope is we'll have time for Q&A so we can discuss particulars of that. When we talk about programming for IoT, it's important to even just to scope that a little bit. So what kind of code do we need to create? What does it need to do? How are we going to write that code? You know, Steve Wozniak famously said, it's not widely quoted, but it's very findable, that one of the key factors that made the Apple computer successful was his choice of language. That he wasn't going to launch a personal computer revolution with a bunch of Fortran programmers. It needed to be basic, because that brought in a different group of people. And who's going to be doing that programming? Clearly some of the people in this room, but who else? And so those are some things we're going to look at. Just a little bit on my background. As Rick mentioned, one of the early projects I worked on was QuickTime. And again, Rick is one of the few people who recognizes, I think, that one of the real accomplishments there wasn't bringing video to computers. Somebody was going to do that. Okay, we got there early. I was thrilled to get to work on it. Honored that some of that code still ships 25 years later. But the things that we did, one was it was built on the premise of a plug-in architecture. So we knew that we didn't know the future of multimedia and that other people were going to need to contribute to that. So we didn't have a plug-in interface for third-party code. We had a plug-in interface for our code that third parties could also use. The other thing is that we knew that if you wanted to have a lot of video content on computers, you needed to be able to make video content on computers. So most of the work we did on QuickTime in the early days was actually for video authoring. And things like Adobe Premiere, which eventually sort of morphed through teams and companies and code bases into what's Final Cut Pro today, are a direct result of that work we did to allow users to generate content, to allow individuals who traditionally weren't part of the video infrastructure to dive into video because computers could now do that. So we're going to talk about IoT, and there's so many definitions of it, I wanted to at least say which part of it I'm talking about today, and that's consumer IoT. So I'm not going to talk about industrial IoT, all the other pieces of it, and I won't even try to explain to you all the different devices in IoT because you've walked around the show and you've seen that. What is important, and this really came out last year at CES, are consumer expectations for IoT. Okay? The first thing is we are taking existing categories of devices, for the most part, and sticking into them an application processor with network connectivity. And that's sort of the fundamental definition. And consumers expect those products to be better than their predecessors. Better is vague, but more configurable, more reliable, more functional. Okay? But the other piece they really deeply expect, and that we've completely missed so far, I believe, is that those things have to work together. Okay? Everybody on the show floor says, "Oh, here's my awesome IoT device, and here's my awesome cloud service that it connects to, and here's my awesome mobile app." Okay? Well, no small company and very few big companies are awesome at all three of those things. Okay? They try hard, they do great work in many cases, but they're better at one than the other. And so we need to make these things work together. If you looked at the articles that came out of CES last year afterwards, it was a lot about the promise of IoT not yet being fulfilled because these devices didn't connect together. Okay? So when somebody starts talking about interoperability, somebody especially at an IEEE event will say standards, right? We can solve this with standards. So let's talk about standards for a couple minutes. And again, grossly oversimplifying, I see kind of the world in two kinds of standards. There's standards that happen before a market grows, and there's standards that happen after a market is established. Okay? In the case, some good examples where you need to have something beforehand is where you have these huge infrastructure investments, right? Like, you're not going to roll out 5G cellular unless you have some standards agreements, because people have to all be building the same thing. You're not going to roll out DVD unless all the studios agree and all the CE manufacturers agree, because you just can't make those investments. So those are kind of standards that are necessary to spark a market. There are also standards that happen after the fact, right? HTML didn't start out as a standard. It started out as Tim Berners-Lee doing what he thought was cool, right? JSON kind of happened by accident because Douglas Crockford decided that was the best way to ship data around. He was going to kind of formulate that. The MPEG-4 file format, which is a standard that I had the honor to work on, was the formalization of the QuickTime file format. And it happened years after we had developed that format, and it was widely deployed. And so there's a question in IoT, which of these kinds of standards do we need? Okay? I'm going to grab some water. I won't be able to talk much more. And there are a huge number of organizations, these are just a few, that are doing very interesting work to try to create those first kind of standards, right? Let us predefine everything that the industry will need. Let's imagine every use case and every possible future, and let's cook that into a standard. And it'll just be a few hundred pages long, and everybody will implement that in their tiny little device, and the world will be great. And that clearly hasn't happened. And everyone's really trying, and they're doing that in a way that's a little bit dangerous. In fact, because what they're trying to do is create their own hubs of standards, their own ecosystems. And think about your home, right? Are we going to see like house for sale signs in the future that said this house is provisioned for iOS? You know, Android users, I'm sorry, because you'll have to change every oven, every light fixture, every wall socket to be compatible. That's the world that we're actually kind of sliding towards right now. And it's nothing against any of the standards work that these companies are doing. They're actually doing very interesting work. They're making interesting products. But you know, the scale of CE and CES is because of interoperability and the fact that all these products can work together. And that's not going to happen if any individual company controls the standard. So my opinion is that the standards work that's going on right now is too much too soon. We don't actually know what we want to do with all these IoT devices. We can imagine, but you know, we're sort of at the stage where, do you remember way back at the dawn of the internet, the example everybody gave of why the internet was going to be awesome is because you could order a pizza with your web browser? You remember, like in every demo, people have pizzas delivered to stage. We're like on that now, like, oh, you can turn on your light bulb when you get home from your driveway. It's interesting, but it's not the real future, right? And so we don't know what we want. We've got these big, giant underpinning standards, and these are leading to very big, complicated devices. You know, a good example is AllJoyn, which has been doing very good work, putting code out there, working with lots of vendors. You know, we were talking to them yesterday, and they said, oh, I think we have 2 certified devices in the market right now. And it's huge. It's very hard to deploy these things well. And, you know, they're doing it right. So IoT needs time to evolve. We've got to experiment. We've got to get experience. We're engineers. This is what we do. We try things. We see how they work. We iterate. We do it again. But it's too early for the IoT standards. It doesn't mean we shouldn't be talking about it and working on it, but we shouldn't be waiting for them. We should be doing products more and more aggressively and learning about it. And we should be building on the existing standards, right? HTTPs, yeah, it's pretty good. JavaScript's pretty good. MPEG's done some pretty good work. JSON, we should, those things that have underpinned everything that's happened in mobile and the PC should underpin IoT. There's going to be some other stuff as well, but we can use that. Now, the one objection that I usually get from people when I present it this way is the cloud. The cloud solves it all. We will just, you know, have every IoT device talk to the cloud. The cloud will gather all the data and then tell everything what to do. This sounds good, and you know, if you're Google, it is your worldview, and they're entitled to one. If you look at the amount of data, it gets silly that you're going to be pushing around. It's just absurd. The internet isn't always there. It really breaks. It really goes down. And you know how like annoying it is when you can't check email for 5 minutes. Like imagine you can't turn your lights on for an hour. It's a problem. Whose cloud? It's not the cloud. It's lots of clouds, right? And whose cloud is going to own all your data? And then there's security. We're moving data around that we don't have to. You know, when I open my front door that has my connected lock, does it really have to tell, you know, I'm in Menlo Park, do I have to tell a server in Washington, D.C. that my front door opens so that the lights in the hallway know to turn on? This is madness. And so the cloud needs to exist and it does useful things, but there's things that we can do locally as well. And so we've got to spread those smarts out across all the different devices. And so I'm a big advocate of direct device-to-device communication. That you can talk to any cloud service, you can talk to any IoT device, you can talk to any mobile app. You know, when you set up a new computer, you set up a new web browser, you set up a new mobile device, you get a lot of choices about what you connect to. You don't get those in IoT devices. You know, they connect to exactly one cloud service. And so we've got to change that. Okay, so that's sort of background on standards and where I see those kind of mattering and fitting in. Let's talk about how we're going to spark IoT growth, how we're going to kind of make these things happen in ways that consumers care about. One of the questions that gets asked a lot when I do interviews comes up, it's like, what's going to be the killer app? Okay? And history is an awesome thing to look at from time to time, and at an IEEE event, it's even better. So this is the computer, one of the early computers I used, actually not the very first one, but still great. This computer, of course, actually had a killer app, and it's the app for this computer that makes us even talk about what's the killer app. And we're lucky to have Bob Frankston, who actually wrote the code for that killer app in the audience today, which is super cool. That was VisiCalc. And VisiCalc was so awesome, so unique, so powerful, that it almost made Apple's business. Like, Apple was doing interesting work, but it needed the right software on top of that to happen. And so it's always now left people asking, what's the killer app? But the key thing to keep in mind is, in fact, that what we're tacitly acknowledging in that is it's the software that makes the hardware super valuable, right? It's the software that lets us do things. The technology, and Gary Shapiro did a gorgeous job sort of talking about all the things that are happening in technology, right? But all that technology, all the amazing things we're seeing right here depend on the software to make it happen, to make it useful and meaningful and adapt to the customer needs. So, what's the killer app for IoT? Well, my position actually is it's the same killer app that it was for mobile. And you're thinking, what is he talking about? What was the killer app for mobile? And in fact, it was the ability to run apps. It wasn't one app, right? Apple thought, oh, we'll build all the apps you need. We can do that. We got a bunch of engineers. We're smarter. Got it. But no, the hackers demanded, they jailbroke things, and you could run any app you wanted, more or less, on your phones. And that's what made smartphones take off, right? And, okay, so IoT, we know those devices don't run apps, right? You're crazy. So good, step one. I've achieved my goal of reaching total insanity in my presentation. You can't possibly be proposing that we'll have user installable apps on IoT devices. It's madness. Those devices, they're not powerful enough. Have you ever tried to install like an embedded SDK? It takes like a week just to get it to compile the hello world. It's no way. Who's going to do that? Anyway, it's so hard to write. The code won't be reliable. It'll crash all the time. You don't want that. And security. Anytime that somebody wants to stop something in IoT, all you have to do is say the word security. You don't even have to explain anymore. People, oh yeah, security is important. We can't do that. Curiously enough, these are almost the exact same points that Steve Jobs used to explain why we couldn't have end-user apps on iPhone. And it seems to work okay these days. So maybe we can solve these problems. Maybe it's not insane. And we have end-user installable apps on watches, which are smaller than most consumer electronics devices today. So we should be able to get the horsepower in there to do that, right? So let's explore the insanity. Let's take a look at an approach to how could we get end-user apps installed on a device so that we could get all the different kinds of connectivity we want, and we could unleash the creativity of programmers around the world the same way we did for mobile. So, standards. My kind of favorite standard by far these days is ES262, which is, if you memorize all these things, is the JavaScript standard. Okay? And why? It's a scripting language, for one, which I think is great because many more people can program in scripts. As professional programmers, when we want to do something quickly, what do? We write a script. It could be in Perl, it could be in Python, it could be a make script, but that's what we do, always. So why shouldn't we use that more broadly? JavaScript is the closest thing our industry has to a universal language. It works on the desktop, it rules the desktop, it's a huge part of mobile, between mobile browsers and mobile apps that are built in JavaScript. With Node.js, it's conquering the server in phenomenal ways. When there's a natural disaster somewhere in the world, a website pops up inside of like an hour or two. To collect donations and exchange information and help people who are impacted, connect with each other and tell their family they're alive. Who does that? It's people who are building Node servers, right? Who know how to just pop up a new website, make it work, and look good and scale inside a couple hours, right? We want those people helping with IoT so that we can move quickly. It's not a 3-year product cycle, it's like a 3-hour product cycle to get a good idea off the ground. It's awesome. So JavaScript has not yet conquered embedded. So I think it's its next great frontier, IoT. And so I'm going to spend some time sharing with you why that actually isn't insane on a 5-year time horizon, because we have experience that shows that it really works. So this is John Bruner of O'Reilly, and he just a week or so ago kind of released his top hardware trends for 2016. And number 2, not number 1, but we'll take it, number 2 was high-level programming languages on embedded systems. John's job is to go to conferences, to talk to startups, to talk to innovators about what they're working on, what the trends are. And O'Reilly's actually published a book on JavaScript programming for IoT and embedded already, based on the JavaScript language using Node. It's not, it hasn't gotten as small as I think it needs to in that particular case, but he really sees it. It's practical. There's people who are using this today, experimenting with it. And it can happen. JavaScript for IoT has some really interesting advantages. The internet, all the data on the internet today, almost all, travels in JSON, which was interesting because, for the longest time it was all XML, which was like a big, heavy, complicated, beautifully written, wonderfully thought out standard. And JSON took over. Why? Because, well, if you have JavaScript running in your browser and you have JavaScript running on your server, you want to use the native data format. You don't have to think about serializing your objects. You just call toString, basically, and out it goes, right? So if your device can talk the native data format of the web natively, you save a huge amount of time. It's super easy. The language is portable. It was designed to run in web browsers, which at the time, and still to this day, run on dozens of different operating systems. So there's no weird historic dependencies on any particular operating system. It's completely portable and OS independent. It also is a garbage collector, which means that memory leaks you can still hurt yourself, of course. Any good programming language lets you do damage, but one of the challenges if you built an embedded product is, okay, it runs for an hour, but does it run for 3 months? Does it run for 6 months without being rebooted? And memory leaks will kill you. And a garbage collector, which is an intrinsic part of JavaScript, helps you with that. It makes you less likely to make those mistakes. It's also, we have to talk about security. And so I don't want to gloss this over, so I'll talk about it a little bit here. Again, there's no silver bullet in security, and I will never make such a claim, but a language can help you. Okay? Some languages are intrinsically more secure than others. First thing is that because JavaScript never had any OS dependencies, it doesn't have all these libraries and objects to call OS functionality. The only operating system functionality you can call in a stock, off-the-shelf JavaScript implementation is date. What time is it now? That's it. You cannot get to the file system, you can't get to sockets, you can't allocate more memory than the VM wants to let you allocate, you can't draw to the screen, you can do nothing. It's all under the control of the system designer. Okay? So you have got this code running in a sandbox, whereas the system designer, you decide what the parameters are, what it sees, what it can do, how much time it can run for. And that's a big deal because you're not peeling stuff back. You're not taking, sort of what some people do in Linux, which is taking a big, huge, wide open system and trying to pare it down. That can be very frustrating. You're starting with a very tight, narrowly constrained system and adding things to it. That's a much more secure way to approach it. The other thing is we've struggled as an industry for years and years and years with bugs in native code. And I've had my share. I read with horror the security bulletins from Apple when there's always like a QuickTime 1 in there, always. And I look at my head, it's probably my code, which is, it's bad. It's humbling, but at the time we didn't have the same kind of attacks that we do now, and so it's a very different world. But it's native code, and you just make mistakes because none of us were trained to think about how to write native code that is going to be immune from external attacks. We were taught about reusability, we were taught about efficiency, but not like evil person 6,000 miles away 5 years in the future trying to crash your code. Like, it's a different thing. JavaScript, on the other hand, because it's an interpreted language, is remarkably immune to those things. There is no such thing as uninitialized memory. If you try to overflow the stack, you'll get an exception. That function will exit, and that will be the end of that. You can't overrun a buffer. Arrays and strings are defined, so it's impossible. If you try to inject bad data, the worst thing that's going to happen is an exception is going to be thrown. It's going to get caught. And you can shut down that particular app, but you're not going to take over the system. The skeptic in the audience will say, okay, but you might have a bug in your JavaScript engine. It's true, but we can fix those, and then we fix every app that runs on top of it. We don't have to fix 100,000 apps at once. So it gives you something that's intrinsically more secure. Nothing's perfectly secure. Don't misquote me on that. Misunderstand me. But it gives us a better starting point for building secure products. Some of you will say, "Oh, JavaScript, that's that toy language. Not for professionals, and it's certainly not for IoT." It's really changed, and a big part of what's changed for that is JavaScript 6th edition, often called ES6 or ECMAScript 6, which is the standards name. And this was the first major revision to the language ever. 5th edition sort of formalized everything that people had been doing. It was one of those standards that I talked about that formalizes best practices. 6th edition is a forward-looking standard. It's the first time that that's happened with JavaScript. And there are literally over 400 changes to the language, most of which you won't notice, and it's still backwards compatible, so they did a fantastic job there. But a bunch of these changes are really powerful for IoT. I can't say they were designed with IoT in mind, but they're going to really help us. For the first time, JavaScript has true kind of classes. It's traditionally used prototype-based inheritance, which is very cool, very powerful, and a little bit tricky to understand. So that's still there, but you can use just classes the way you're used to for inheritance. There's promises for asynchronous, managing asynchronous operations, and that again was sort of ad hoc in JavaScript before, and they formalized promises from Node.js. This is a way to manage asynchronous operations, right? And in IoT, you're doing network requests and watching for button presses and all these things you can't block, so the device stays responsive. And so promises are a great tool for that. Another knock on JavaScript is it was hard to reuse code, and they introduced modules which are rigorously formal, beautifully done, and allow for reusable code libraries, just like you have in other languages. And then the other piece, which is really great for IoT, is they have these things called array buffers, which they borrowed from the WebGL work, which are a way to work with binary data from script. So, again, in JavaScript, you used to really only be able to work with strings or do these weird tricks to kind of deal with binary data. And now you can work with blocks of memory directly using array buffers and still do it in a safe, sandboxed way. So these are big things for JavaScript. So then the next question, you're saying, oh, good, that sounds nice, but, every JavaScript engine I've seen is designed to work in a web browser. And when it starts up, it needs a couple hundred megabytes of memory and a gigahertz processor, and it's using a multi-threaded generational garbage collector that needs a couple cores to run well. And it's because this has happened because all the JavaScript engines have been developed for the web, and they're trying to get as much performance out of that as they can. What if somebody built a JavaScript engine for IoT? Well, that's what my team's been working on for some years now. And so this is what we're doing. I'm going to talk about. I'm going to talk about my work. I will point out that there are lots of other people playing around with JavaScript for embedded devices. We're far from the only ones. Everybody's got a different set of priorities and is doing interesting work. I like the work my team's doing. I'm proud of it. If somebody else's JavaScript engine conquers the world and is used in every IoT device on the planet, I will congratulate them and find something else interesting to work on. So I'm sharing my work because I know it, but feel free to look around. There's lots of good stuff going on. So the smallest system you can run JavaScript on that we have today is a chip that my parent company Marvell makes called the MW302. Chip names are awesome. It has built into one chip a ½ megabyte of RAM. I will say that again, megabyte, kilobytes, 512 KB, not half a gigabyte of RAM, half a megabyte of RAM. 200 megahertz ARM processor. On that same chip is built in Wi-Fi BG, which is very cool. So one chip gives you kind of connectivity and application processor. And we have an ECMAScript 6th edition implementation that runs on that, that's open source. The coolest thing, from my perspective, is not only that it runs on there, but we have in that ECMAScript 6th edition implementation, not a stripped down and embedded version. We have the most complete ECMAScript 6th edition, JavaScript 6th edition implementation on the planet. There's a site that tracks it. We have 97% of the new features implemented. The next closest company is Microsoft, who has a few more engineers than we do, at 81%. And then you drift to Mozilla at 60-something, and Google and Apple and below 50%. So not only is it possible to do JavaScript 6th edition on mobile hardware, but you can do it ahead of like the big guys who are playing on the browser. Now they'll catch up. Google's good. I'm not going to ever out-engineer them. But the point is you're not dealing with old technology unembedded, which has been the case. Usually you're using technology 10 years old because that's what fits. You can use the latest stuff. We've open sourced all this so you can pull it down. This chip, just to give you a sense of where it goes, one product that it went into, it's not using JavaScript yet, but I hope it does, is from Mattel, and it's the talking Barbie, Hello Barbie, that's out there. And so this chip goes into into products. It's an $80 retail product. It's a toy which has crazy margins. And so you can make very inexpensive products with this that are scriptable, of all things. And so that opens up all kinds of interesting possibilities. Now, let's take a look at what does JavaScript look like on an IoT device? Because it doesn't look exactly like what you see in the web browser, of course, because we're doing really different things. In fact, most of these devices don't even have a screen. So since the core functionality of IoT is networking, I thought a couple examples of what does a HTTP connection look like, something that almost everyone who's coded at this point has coded. So this is a simple HTTP client, and it's using 6th edition features, which I won't get into too much, but the big one to notice is that require statement at the top. And that's how you import code. It's one of the ways you can import code as a module in JavaScript. So we don't say use the HTTP object, we just literally at runtime pull it in. Say, okay, I want to use it. Then we can conjure up an instance of an HTTP client. We add a couple callback functions, one to say when the transfer is done, one to tell us what data is available, and then we start it. And this code will make an HTTP request, trace the data to the console, and be done. And so again, the nice thing is, from a scriptable perspective, and it's not that I skip the error checking, it's not that I skip the memory management, that just kind of happens. And the nice thing is, that fits comfortably on a slide with giant type. Right? So it's the kind of thing that people can really do. It's not hard to learn. JavaScript is a language that students are using. It's becoming more and more the language that they're teaching in schools. And so it's very approachable. Let's look at a server. The cool thing about a server is actually the server is smaller than the client. And an IoT device really should be a server. So again, we do a require, we bring in the module that implements a server, we open up on port 80 or anything else you like, and then we just have a callback function for when a new request comes in. And in this case, we don't do much, we just literally trace out that it happens and respond by posting the connection down, but you could push some data in there and do whatever you like. But the point is, brain dead simple to do an HTTP request. And we have the same things for this, for MQTT and for CoAP and for WebSockets, right? And you can add your own network protocols. We added in our engine, we wrote all of our network protocols in JavaScript. So you can take our HTTP implementation, look at the script, add the features you need if they're not there, but we wrote it all on the low-level sockets object. So if you want to invent a new protocol or implement a new protocol, you can do it all in the script. Super easy to do if you know what you're doing on that front end, and very open and powerful, right? So we're not saying we know what the protocol of the future is. We don't. We might have guessed right and we might have guessed wrong, but go ahead and play it and figure that out. Another big thing for IoT is, in addition to the application processor and the network, you have some sensors and some actuators, right? Some blinking lights or whatever, and you need to talk to them over I2C or serial or GPIO or analog. What does that look like? And again, just one quick example. This is an I2C based accelerometer, and we have I2C bindings in JavaScript. And in this case, we just say make a new I2C connection. The parameters could be more obvious, but it means the first bus and I2C slate address hex 53. And we do a read to make sure that we're connected to the device we expect we are. And then we configure it briefly, and then we start reading XYZ coordinates off of it. And if you're an old school C programmer like me, the byte massaging and shifting to get your byte reads into words with the proper idea, and this looks very familiar. And it's one of the things that I like about JavaScript is it has a C-like syntax. So if you're a C programmer, you can start using it like C. You should learn more and start using it like JavaScript. The features that are there make sense, but you really can kind of slide in. I have one guy on my team who loves Java, and his JavaScript looks exactly like Java. Exactly, it's funny. So it's adaptable to your styles. But the important thing here is the code is simple. It's straightforward. If you think that our I2C object design is awful and you have a much better idea for how to write scripting code to access it, go for it. We publish all this and you can do that. So, these are just ways to do it. When I say go for it, I really mean it. So, how would you add scripting support to your existing product? Right? It's not that bad. I'm assuming we're lots of engineers in this room, so I'm going to show you a little bit more code. I won't go through every line, but I think it's useful to see it to get a sense again of what's involved. Our engine's called XS6. You can grab it off of GitHub. It's all in ICCE, no fancy C++, no nothing. We did that on purpose and with great pains so that it will run on just about any embedding device you can find. There are all the platform dependencies, if we did our job right, are just 3 files. So if you have to post it to a new chip or a new operating system, you can do that, or you can use the support we have for a bunch of existing ones. I'm going to show you how to run this very complicated script. If you can run this one, you can run a lot more. So this is the native code that you need. This is C. This is native code you need to run that script. And basically what you do, again, without going through every line, is you set the parameters for the virtual machine, how much memory it should use. This is actually a little on the big side, but it works. You say create a virtual machine. You say, okay, begin host, which means I'm going to start running a script. In this case, we call a function called run program, which loads a script from source code off of a file and compiles it to bytecode and sticks it in the VM, and then it calls it and just executes it. So that hello world will trace out to the console after that, and then we tear everything down, right? End host and delete machine, and that's it. You can do lots more, and I'll show you one quick example of that. But that's all the code you need to take your existing product and start adding scripts to it. You've got to bind our library in and all that stuff, and it's not 3 minutes work, but in a lot of cases it's a day or two's worth of work to start exploring what would it mean to make my product scriptable. Okay? So you're saying like, okay, I need to do more than trace, I need to do more than date. How can I tie into native functions? So I'm going to give you a super simple example. Say you want to get an environment variable, right? So you want to add a get and function to JavaScript language. What you do is you implement that function in C. So first you have to tell the JavaScript engine, here's my function, and you do that with this new host function thing, which basically gives the connection between the native function implementation and the JavaScript function name, get env. So it's 2 lines to do that. And then it's a global function. And then I have to write the C version of that, which in this case basically gets the name of the environment variable from the script, calls the native get environment function, and then passes that C string back as a JavaScript string. So again, 3 lines of code. You're going to do something more interesting in this. It'll take some more lines of code. But if you've ever done JNI bindings, if you've ever bound to Google's V8 JavaScript engine, if you've ever done Python bindings, this is very familiar. And once you've done it like 4 times, you can do it in your sleep. And it lets you bind any native code you need into your JavaScript engine. So you can control and you can add what people want. What we do, so that's one side, which is make your product scriptable. Okay? If that's all you do, you're awesome. And you're contributing to letting IoT really grow in an organic way where lots of users can contribute and explore and find the best uses, the coolest, most valuable uses of your hardware. My team tends to go deeper than that. Again, we're a little either obsessive or insane, it doesn't matter. We actually will build almost the entire product in JavaScript, where these are actually examples of real-world products from Sony, from HP, and from my team, where all of the application logic, all of the user interface, all of the network, all of the top hardware are built using our JavaScript engine. They're out there in the world, they really work, they're super reliable, and the great thing from the perspective of our customers is they're better products for it. Because when you're working in JavaScript, you can get the first thing working much faster. You can simulate it on the desktop easily. You can iterate really quickly, right? What's the thing that kills products? What's the thing that like atrophies so many companies? Is like, oh, we don't dare touch that code. Like it works, we don't know. It's too hard. So we spent 6 weeks getting it working. No. JavaScript, more and more people can go tweak the code. They can do that more quickly, more safely. There are so many JavaScript programmers in the world. You can leverage all kinds of cool things they've done, libraries, techniques. It's hardware dependent. When you're building hardware, it turns out your software lives way has a way longer lifespan than your hardware. Right? Every year there's a new chip, a new generation, but the software just keeps on going. Some of the code, it's phenomenal, some of it's amazing. Some of the code I wrote 25 years ago at Apple is still running in Apple products. They'll eventually get it all out, good for them, but the lifespan of code is much longer than hardware, so being platform independent is a big deal. The other thing we found, which is really spectacular with one of the customers we're working with, is that finding embedded programmers is really hard. Not in this room, perhaps, but in the real world, it's a real challenge. And finding JavaScript programmers is pretty easy. They're literally teaching it to high school students. They're teaching it at universities. People are teaching it to themselves. And so anywhere in the world, you can find some JavaScript programmers. And they're much less expensive than embedded programmers. And we have done some work with one of our customers where we recruited web developers with like 2 years of experience to work on the core experience of their IoT products. And it's working great. A little bit of training and they're off to the races. We did something similar with a 3D printer. We built a 3D printer prototype with a 3D printing company. They'd never used our technology. They'd never built an app in that style of JavaScript. And in 2 months, they have an awesome demo that we shown here at the show. So you can tap into a much bigger market of innovative programmers if you're working in a scripting language like JavaScript. Now, I've said JavaScript is awesome a few times, and you probably got that message. One thing I want to be clear about, don't fall into this 100% pure trap. This is something that sometimes seeps in. Native code is awesome. Use it where you need it. Don't be afraid to use it. You need it to reuse existing code in your product that you may have. You need it to access native functionality. Sometimes you need it for security reasons, and you absolutely need it for speed reasons. JavaScript engines will never be as fast as native code, ever. So use it when you can do that. But don't, use it as much as you can, we believe, but don't ever try to be a total purist, or you'll just lose. There's some other common objections. Some people say, oh, it's got to be, JavaScript is a dynamic language, it's not type safe, you can't make reliable products with a non-type safe language. This is debatable, but imagine it's true and your manager is unyielding. Use TypeScript. It's a language that Microsoft developed. It's a type-safe version of JavaScript that compiles down to JavaScript. So any JavaScript engine can run TypeScript code. Google says JavaScript isn't good for big projects. They use this to try to convince you that Dart is important, and Dart's cool, actually. With modules in ES6, it's much better for big projects. And with type-safe things like TypeScript, also much better there. They also tell you JavaScript isn't fast. And so, use native code where you need to. You don't have to use it for everything, but just because it's not fast at everything doesn't mean it's not useful for lots of things. The other major point we talked about is, so who's going to program the Internet of Things? That I asked at the beginning. Anyone isn't going to write code, but is it just the embedded programmers? No. So customers are getting incredibly sophisticated. With IoT devices, they're running all kinds of really powerful, sometimes bizarre, user interfaces to configure and control their devices, right? They never give them quite the control that they want, right? A lot of people say, I wish it would do this. Well, there's nifty services, if this then that, if you haven't played with it, you should, brings exactly one part of a programming language to Internet of Things, the if statement, okay? And a beautiful graphical interface around it so that lots of people can automate certain tasks. My only knock on if this then that is that it's always in the cloud, and I'd like it to be able to run locally as well, but it's a superb proof point that you can tie together all these services and do it in a way that lots of people can use. Writing source code is a skill, and it takes a discipline, and for a lot of people that writing of source code is an impediment to getting started with coding. There's really superb visual programming languages out there now. There's Scratch, which every elementary school student seems to have some familiarity with now in the United States. Google's using Blockly, which we like a lot, which is almost a successor to Scratch. It's an on-ramp to real coding, and the reason I like it is Blockly was designed to generate JavaScript source code out the back. So you can actually do a view source of your blocks, of your visual programming, and see what the JavaScript code is, and sort of start to learn scripting by making visual blocks. And we've used this successfully with fifth graders. We hosted an after-school program, and they were doing client-server interactions, they were turning on and off lights, they were building user interfaces, all with blocks, and no problem. It's a really nifty way, and I think it's going to be something for IoT that's going to be very powerful because it brings programming with all its constructs to more people. And then, of course, JavaScript, which has proven itself to be a really widely accessible tool. In looking ahead at IoT, scriptability is going to give you scalability, right? When you say we need to connect to these 50 different cloud services to be a competitive product, it's going to take us forever to do the deals for that, we're never to write all the code. If you make your product open, everybody can plug into it. Everybody in the world who wants to make your product better, who's got it in their home and wants to make it their own, can do that for you. So you don't have to do everything directly with other companies. Scriptability is going to get us to the right standards. We're going to figure out what needs to be standardized by the things that scripts are doing over and over again, by the modules that people build, by the things that are almost the same between two different products. And we're going to find that out a lot faster. We're going to find that out with input from a lot more people. And that will force all kinds of changes, maybe into future versions of the JavaScript language itself. And that's really what's going to make, I believe, IoT take off. It's getting some of the software plumbing right. The standards let us work together, But openness lets us work together. Open source achieves that, and openness of protocols, openness of scriptability lets us kind of loosely assemble and build things that make sense, so that we can get to the scale that we see here at CES. It's not a central control of design program. It's really an organic experience that's going to make this happen, and that's going to get consumers what they expect. If you show a consumer an IoT product and say, what do you expect it to do? They'll tell you, and it's never exactly what the product does. And if you let them have it in their house and use it for a few months, then they'll really tell you like what they think of it. And generally they'll be charmed with some part of it and annoyed with some other part of it. And so, as we make these devices more open to anybody to put their code on it, to interact with it, we will find the right models more quickly and help grow IoT to what it should be. So that's my talk for this morning. I want to thank you for your attention.
Can you bring up mic number 2 here?
Number 2, thank you. We have time for some questions. We don't have an audience mic, so can I ask you to kind of come up here, and I will hand you this one, and keep your questions short because we are running into the break. So short question, short answer.
Actually, I just want to endorse what Peter says. I've gotten into JavaScript a lot lately, and TypeScript, I put it in a plug. It's really becoming sort of more accessible. The other thing I want to add is you mentioned Visicom as a killer app. The sense with the killer app was having the app was an open game machine that gave us the opportunity. So this openness, I mean, it's outside that comes on the IEEE to learn by doing.
Right. Thanks, Bob.
I guess I have a question. I know, and I'm sure everyone in the room is aware that it didn't start out as with the name JavaScript. It started out as LiveScript from Netscape, and it really came from a very different place, Java. But now it seems to be evolving to the point where it's doing almost all the stuff that Java does that people used to call from JavaScript. So is there still a role for Java as a language, or is JavaScript, in your view, something now that can handle, I don't want to say 100%, but much larger, almost everything kind of applications?
Yeah, I think everybody has like a language preference, and so I would never kind of say like one language is better or not. I think people's practice working in a language and how efficiently they can work together is what matters. So Java has an incredibly powerful role on the server still to this day. But I think in terms of the client, JavaScript has really won because of its role in the browser. And that's why for IoT, I think we would be wise to use the thing that has been well established, rather than trying to take something else and transplant it in.
Another question here?
Hey, Brian Zonsticker, PowerDocs. Thank you. It's very interesting talk. I enjoyed some of your perspectives, especially being a hardware guy with a little more lay on the software coding side of things. I'll like you dumbing it down for me. But speaking of that, I'm curious if you could comment on how the scripting application to this that you're promoting applies specifically to things like enabling mesh networks and how that's going to be very powerful for IoT devices and taking something from the big network that we go up to having everything be smart and self-contained.
I think mesh networks have been on the verge of being a big thing for so long. It's we're all kind of waiting. It's an incredibly intriguing possibility because the network's reliability isn't always there, and local communication matters a lot. And I think what scripting lets you do is again just have more people try different things and more quickly find out what works. Those infrastructure investments, once they're there, once the radios can talk, that's just the potential to communicate. What we communicate? What's a good use of mesh networks? What's the best use? We haven't really found yet. I believe, and so we need to let more people play with that, and that's where scripting can really help. All right.
Thanks for that. That was wonderful. I'm just getting into IoT and going to meetups. That's always really interesting. So you were talking earlier about where the App Store really seemed to change how people get access to the functionality that they want because they can choose to do whatever it is that they want to do. Do you see that? Well, A, how do you see that happening? And B, the way I understand as a software engineer that happening is maybe that huge ecosystem of already existing scripts become the libraries that everybody uses, just like jQuery is what really changed JavaScript. We end up with IoT query, or embedded query, or mesh network query, etc. So how do you see all that playing out?
I think, we will get to app stores for IoT. I think the things that you see around the Apple Watch, the way you get apps there is a really good kind of hint of how that might look down the line. And you're absolutely right. The language is the foundation, right? But jQuery is a perfect example of the right library really lets a particular market take off. And IoT is interesting. I don't know if you'll end up with an IoT, specific library or something that is, oh, this one's good for 3D printers, this one's, good for home control, this one's, good for automotive kinds of things. I think there's a lot of ways that could evolve because it can be very specific and that lets you get to very specific functionality.
So do you see where that might fit in with like NuGet and Bower and NPM? That's how they bring it all in? Yeah,
no, Ari asked specifically about how Node has this beautiful, beautiful mechanism called NPM. And everybody who's Node is just, oh, you just NPM install this and you're good. And it seems like some magic thing, and it's what brings in new libraries. And yeah, I think that's now supporting kind of standard JavaScript modules. That's the way they came through. And so yeah, I think you're going to get there where you can basically NPM install the moral equivalent of that to your IoT devices to bring in new functionality. And again, end users won't naturally all do that, but we'll wrap that up in some pretty interface that makes it easy for them to do that, and we'll get that layer of flexibility. So I think we're at time, so I will thank you for the opportunity to talk to you. I'm really happy to kind of share with you our vision, my thoughts and experience on where this could go, and I hope you'll take a look and think about it some more so you can help contribute to it as well. Thank you.
Thank you so much. Rick has a little presentation here for you. We'll hold you just for one more minute.
Peter, wonderful talk. Raised a lot of questions and means the theme of our conference. I'm having a very grateful IEEE. I'd like to present you this slide.
We have a couple of closing announcements before we break. I'll make one of them, and then Bob Frankston's going to come up. He has something to say as well. First, let me tell you that we actually do have a mobile-friendly version of the program. It's a PDF you can download to your phone or whatever that can run a PDF. That's the URL or the QR code. Please think about downloading it because I think you'll find it to be a useful enhancement. And then I also want to just indicate one other thing before I turn this back to our program chair. If I can get the screen to come up, which looks more difficult than it is. Well, let's try this again. I'm not having any luck with it, but let me tell you what I have in mind. We do have a Sunday social event, which will start at the end of this conference. It begins at 6 o'clock. It is a ride on something called the High Roller, which if you walked outside and you looked up in the sky, you've seen it. It's this gigantic Ferris wheel with self-contained cabins. We've obtained a special price that includes 2 drinks and a 30-minute ride with food and any possible tray inside there. There'll be 30 people or so inside each of the different gondolas. We have already sold 90 tickets. We have a capacity for 105 people. So there are 15 tickets still available for that. You're going to need to pick them up today or at the latest tomorrow morning. The event is Sunday night at 6 o'clock. And if you want a ticket, see Charlotte. She's got them. They're $50 for an additional ticket for a ride up in the, and also the company and companionship of your fellow colleagues here. Bob?
Just want to mention, this last minute change in schedule and 10:30 tomorrow, that's going to be very complimentary to this talk. So I'm going to talk about the connectivity and things you need to connect the devices, which answers the mesh network and other questions.
So any closing announcements that you want to make before we break?
Okay, yeah, that's it for the morning session. I just like to remind you that I think we are a bit behind time, but I think we should have enough time for our break of 20 minutes. So the program will continue as scheduled, starting the session will start at 11, right after the okay, thank you.
One more announcement here with professionals.
Hello everyone, just a reminder for Young Professional evening, this evening, in this location, the same location, at 6 o'clock. We're going to start 6 o'clock. Those who didn't get a ticket, they're welcome to attend, but I can't guarantee you will get a meal. So we'll see you at 6 o'clock. 6:30, sorry, 6:30.
Okay, I guess we are adjourned. The breakout sessions begin at 11 o'clock. Take a look at your downloaded mobile-friendly PDF program.
Sabrina, Heather. Yes. I'm the minority vote in my household.
Can I get a copy of that?
Yeah.
Sasha's really into the IoT stuff.
Yeah, I'll be probably in 256.